Hey guys, welcome to video 2, finding several polar coordinates for the same point. So in this first image here, you see we're given a point. First of all, let's figure out what that point is. It's 1, 2, 3, 4 units out from the origin, and it's at the 30-degree line. So 4 comma 30 is this coordinate. It's r comma theta. Now another way to represent this coordinate would be r comma theta minus 360, because 4 comma 30 is 4 with a 30-degree angle counterclockwise, but I could think of this as a clockwise angle, which will be a negative angle, and that would be coterminal to 30. And so that would be 4 comma negative 330. And I get that by doing 30 minus 360. And so this is the same as negative 330. The 30 line and the negative 330 are the same line, and 4 out is the same thing. So there's two ways to represent the same point. Or I could think of it as a negative r and my angle plus or minus 180. What we mean by that is, remember what the negative angles are. If I had the point, let's say, negative 4 comma 210. Negative 4, 210. What would that look like? Well, remember, you go to the 210 line, which is a reference of 30 off of 180, and this would be positive 4, 210, but because it's negative 4, we shoot across and we end up in the same spot. And so what you could do is you could make your r negative and then add or subtract 180 to get to the opposite side of your grid. I say add or subtract 180 because depending if you're greater than or less than 180, you want to add or subtract 180. Like, because I was less than 180 at 30, I added 180 to get to the other side. But say I started at 210, I would minus 180 to get to 30. I wouldn't add 180. Well, technically I could. I'd end up at 390, which is, again, another way of representing the same angle. But anyways, we're going to try to keep it less than 360 for this, or between negative 360 to positive 360. Anyway, so one more. So another option is to keep your r negative, and then take that 210, which came from theta plus or minus 180, and minus 360 to that. And so negative 4 comma, let's see, this would be negative 150. And what we're saying is this point here, this line, this 210 line, is also the same as the negative 150 line, because it could be clockwise negative 150 degrees instead of counterclockwise positive 210. And so you could do it with positive or negative angles. And so that's how you do it. So let's look at a couple of quick examples, and we're going to use these steps. Basically what we're going to do is we're going to have a regular point. We're going to subtract 360 to it to get it from the other clockwise versus counterclockwise way. Or we can make our r negative and then plus or minus 180 to get to the opposite side, and then even from that we can minus 360. So these are the 4 ways we're going to represent a point, and you'll be given one of them. So really there's 3 new ones here that we're going to use, because you'll start off with a point. Like in this case, 5 comma 225. First of all, let's plot this. 225 is right here. This is your 225 line. And again, I just kind of have these memorized, what they are, but this is a quadrant 3 angle. It's 45 degrees away from 180, and so that's how I remember that this is the 225 line. 5 out would be right here. So this is the point 5 comma 225. Another way to represent it would be with a negative angle, and I can just take my 225 and minus 360. And 225 minus 360 is negative 135. So negative 135 is another way to represent this. Or I could think of r as a negative 5, and think about the opposite point, and that would be 45. And where I got that from was taking my original angle 225 and minusing 180. I'm not going to add 180 because I'm over 180. I'm going to minus 180 to get 45. Remember, plotting the point negative 545, this is the point positive 545. But because I'm negative 5, I would shoot across and I'd end up here. And then lastly, I can plot that with a negative angle. So -5, because this 45 I had here could also be thought of as -315. -315. And what you end up realizing is that you'll end up with a positive or negative version of a quadrant reference angle set, like 45, 135, 225, 315. Those are all the references of 45 in the various quadrants. I have two of them as positive and two of them as negative. Because this line 45 is also -315, and this line over here of 225 is also -135. Let's look at another example. -3, 120. So this one where the r is already negative to start. So let's plot it first of all. The 120 line is right here. And this would be a +3, 120, but -3, 120 is in the opposite side. So this is really where our point is. And so I can stick with that being negative for now and just take my 120 and -360. That's probably the easiest way to get to that next point. And that's going to get us a -240. So this 120 is the same as -240. This 120 line is the same as the -240 line. And I could, -3 is going to shoot across to where I want to be. Or I could use a +3 and add 120 to it, right? So if I add 180 to it. So if I add 180 to my 120, that's going to get me to my opposite side. And adding, that'll get me to 300. So this was 3, 300. I think that's probably the normal one, right? That's the positive r and the positive angle. And we see that this is, let me just move this over. This is a 300-degree line, and we're 3 out. So that's the normal way of expressing it. And then finally, I can take that angle of 300 and -360. And I'll get a -60-degree angle. So -60. And again, I see I end up with 120, -240, 300, 600. All these are references of 60 degrees. 2 of them are positive, 2 of them are negative. I end up with 2 having positive r values, 2 having negative r values. And so these are the different ways I can represent a polar coordinate. See ya.